Thank you for joining us. I'm going to be looking at a little bit of statistics in the Bernoulli distribution, the Bernoulli sequence. And what happens with the Bernoulli is it's like there's a probability of a success or a probability of a failure. Now, we've got probability of a success, we're going to use a P, and probability of failure, which is 1 minus P, which is considered to be Q. And the probability, what happens then is we repeat this activity n times. So every time we repeat the activity, we're going to have the same probability of success and the same probability of failure. Now, if we have a probability of success is 0.5 and a probability of 0.5, what we will end up having is we will have a normal distribution centered around the mean of how many we expect to win. Now, let's say that we have an n of, say, 12. Let's say we're going to play 12 games of tennis, and the chance of winning a game is 0.5. The chance of losing a game is 0.5. So what's from the previous lesson, NPQ? Do you remember how to calculate the mean and the standard deviation? Well, the mean was NP, which in this case is 12 times 0.5, which is 6. And the standard deviation is the square root of NPQ. And that is 12 times 0.5 times 0.5, which is the square root of 3. Just looking at my computer screen. Just wondering if we're still sharing. I'll just assume that it's still sharing. 0.5, 0.5, 12. Now the mean was NP, which is 12 times 0.5, which is 6. The standard deviation is the square root of NPQ, which is 12 times 0.5 times 0.5, which is square root of 3. Now, what we end up having is a normal distribution central which is pretty symmetrical. So we get a mean of 6, up root 3, up root 3, up root 3, down root 3, down root 3, down root 3. So that's 6 plus root 3. That's 6 plus 2 root 3. And that's 6 plus 3 root 3. This is 6 minus root 3, 6 minus 2 root 3, and 6 minus 3 root 3. I'd like to highlight that this is the mean minus 2 standard deviations. This is the mean plus 2 standard deviations here. And the area between down 2 standard deviations and up 2 standard deviations from a previous, you will recall, is 95%. So we've got a 95% probability of between the mean minus 2 standard deviations and the mean plus 2 standard deviations. Well, that's a little bit of revision. What I want to talk about today is how many successes will we expect to get in 12 games. Now, the probability of each one of these is depending on what's called the Bernoulli sequence. So to have 0 successes, like this is the number of successes, all right? To have 0 successes means to have the probability of 0 successes, I'll put 0s, is equal to 12C0, P to the power of 0, and Q, I'll put 1 minus P to the power of 12. So that is 12C0. If you put that in your calculator, you could either use 12C0 or you could use 12 factorial over 0 factorial and 12 factorial. These two numbers must add up to 12. 0 factorial is 1. Be careful of that. 12 factorial means 12 times 12 times 12, 12 times 11, sorry, times 10, all the way down to 1. And so this is equal to 1. 12C0 is equal to 1. P0 is 0.5 to the power of 0. That is 1 again. And 0.5 to the power of 12. So you've got a very small chance of winning no games. The answer is 0.5 to the power of 12. So I'm just going to put here 0.5 to the power of 12. That's a very small number. The probability of one success is equal to 12C1, P to the power of 1, and Q to the power of 11. Notice here I put a 1 minus P, here I put a Q. That's the same. P and Q, that's 1 minus P is equal to Q. So what's that? That should be one success. Probability of one success equals 12C1 is 12. You can calculate that. 0.5 to the power of 1 and 0.5 to the power of 11. These two numbers also add up to 12. All right. This is one success, 1P, and so 11 failures. So we've got 12 times half to the power of 12. So I'll put here 12 times half to the power of 12. So that's the probability of one success. And I'll do one more, the probability of two successes. So the probability of two successes is 12C2, P2, Q10. Now 12C2 is, and if I was to use factorial, 12C2 is 12 factorial over 2 factorial. That's where I get the 12 and the 2. And 2 plus 10 makes 12. So this other number has to be 10. You can get that on your calculator by using your old calculator. And there is a C button. Look for it. And on my calculator, I've got a C. I've actually got an NCR. So I'm going to go 12C2. It gets 66. 12 factorial, you can press the 12 factorial button on your graphic calculator, divide by 2 factorial, or divide by 2 times 10 factorial. You should still get 66. Times 0.5 times to the power of 2, 0.5 to the power of 10. So we've got half to the power of 12 again. So I'm going to put here 66 half to the power of 12. Now, there's a probability. We've only worked out the first 3. And the formula that I'm using, I'll put in orange, the probability of, and I'll take this formula straight out of the textbook, probably that we have x equals, say, 1 success, or x equals 2 successes, or the probability that this was x equals 1 success, this was the probability that x equals 2 successes, this was the probability that x equals 0 successes, equals. And we've got n, that's not the formula, we'll get the formula. Okay, it's on page 598. So it is NCX P to the power of x, very similar to what I've been doing, and Q, they've got a 1 minus P, to the power of n minus x. Remember that these two numbers have to add up to n. And that is the formula that I've been using for each one of these. So if I had the probability, I'll do one more. If I can. It's not working. Come on. It's disappeared. Let's try that again. And I hope that the whiteboard did not delete in the process of blinking off. If it did, I'll just have to finish there, and you can replay it for the whiteboard. No, it's just a little bit larger. I'll use the touch screen. Okay. Oh, okay, that's right. Now, I was about to do the probability of 3 x equals 3. So let's use this rule. N is 12, x is 3. That's 12C3. P is 0.5 to the power of 3, x. And 1 minus 0.5 is also 0.5 to the power of 12 minus 3, which is 9. And that is the formula to get the next value. All right. Okay, that should kickstart you off for exercise 14A. We have done this before, but I'm just going to go through an opportunity for you to complete the exercises in chapter 14. And so I want you to work on 14A. I'll make another follow-up recording, and I'll randomly select some different questions. I've only done 0.5 and 0.5. And I've spoken about the fact that if we have 0.5, we have what's called a symmetrical distribution. It will be skewed if we have different probabilities. I'll talk about that in the next video. All right, until I speak again, stay happy.